Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video on converting recurring decimals to fractions. So we did the other way last time. We converted fractions to their recurring decimals, but this way is unfortunately quite a bit harder, so make sure you pay attention. So just a quick recap. Remember, we found that recurring decimals go on forever. And remember, there's always a pattern to those numbers that go on forever. So any fraction can be written as either a terminating or a recurring decimal. There is another type of decimal, but we're going to go through that in a later lesson. So if I give you any fraction, whether it's 3 over 5 or 207 over 4,190, it can be written as either a terminating decimal or a recurring decimal. So on the other side of that, if I give you any recurring decimal, you will always be able to write it as a fraction. So just for an example to recap, remember we saw in a previous video that if I have 0.666 and the 6's go on forever, I write it like this. The little dot above the 6 indicates it goes on forever, and that was the same as 2/3. So they are the exact same number. Another one we did, we found that 0.6363, which goes on forever. So I put a dot above the 6 and the 3. That's the same as 7 over 11. And we're going to look at how to go from something like this to something like this, okay? So I'm pointing out that this isn't easy, so I want you to pay attention. So I'm going to start on the next slide. Please pause and copy down if you need any of this. So I'm going to start with the number 0.4 recurring. So that means 0.444, the 4's go on forever. And in exact decimal form, I just put a dot above the 4 to indicate the 4's gone forever. What I'm going to do with this recurring decimal is I'm going to turn it into a fraction. So what I do here is a process. I multiply this decimal by a power of 10, then I subtract, and then I get a fraction. Okay, probably doesn't make a lot of sense now, but hopefully it will in a second. So this is how I'm going to start all of these type of questions. I'm going to let x be the recurring decimal that I'm interested in. That is what I want to find as a fraction. So I essentially want to turn x into a fraction. So I'm going to let x equal 0.4 recurring. So remember, that means x is 0.444, goes on forever. Now what I want to do is times x by a power of 10, either 10, 100, 1,000, or whatever, so that it doesn't change what happens after the decimal point. So if I times x by 10, so that means I now have 10x. Remember, timesing by 10 moves the decimal point one spot to the right. So 10x will be 4.444. The 4's again go on forever. So I have not changed what happens after the decimal point. So this is just 4.4 recurring. Okay? So it's important that when I choose what power of 10 I'm going to times x by, what happens after the decimal point doesn't change. Okay? So x is 0.44444. 10x is 4.44444. Now what I'm going to do is I'm going to subtract these. So 10x, which is 4.4 recurring, minus x will give me minus 0.4 recurring, like that. Okay? So, because the same thing occurs after the decimal point in both cases, I can just get rid of what's after the decimal point. 4.4 recurring minus 0.4 recurring. All these 4's will cancel out. 4 minus 4 is 0, 4 minus 4 is 0. They just cross out, and I'm left with a whole heap of zeros here. Except at the start, I get 4 minus 0 is 4. So 10x minus x is 4. This minus this just equals a whole number 4. So we've got 10x minus x equals 4. But hang on, 10x minus 1x is just 9x. So 9x is equal to 4. I want to get x by itself, because remember, I want to find what x is as a fraction. So I undo, this is 9 times x, I undo timesing by 9 by dividing each side by 9, and I get x equals 4 over 9. So I've done it. I have converted a recurring decimal to a fraction. 0.4 recurring is the same as 4 over 9. I'll do a couple more examples and I'll do them a bit quicker now. So please pause and copy down if you need this. So I'm now going to look at this example 0.24 recurring, where both the 2's and the 4's go on forever. And again, in exact decimal form, I put dots above the 2 and the 4. So I'm going to turn that into a fraction. So same process, I let x equal what I'm trying to convert to a fraction, 0.2424, okay? So I want to times x by a power of 10 so that what happens after the decimal point does not change. So if I times by 10, I'm going to get 2.424 and so on. I don't want that because 10x would mean that the number after the decimal point starts with a 4. So it's not quite the same. I don't want that. I want to move the decimal point 2 spots, so that the numbers after the decimal point start with a 2. So to move the decimal point 2 spots, I need to times by 100, the next power of 10. So 100x, I move the decimal point 2 spots to the right, and I get this number. So you can see that what happens after the decimal point here is the same as up here. So now the next step is to subtract. So 100x minus x, that will give me 100x, goes on forever again, minus 1x, the original thing. Okay, and as you can see, all these cancel out. 4 minus 4 is 0, 2 minus 2 is 0, and so on. All of these stuff cancel out, makes it 0, and I'm just left with 24 minus 0, which is 24. So 100x minus x is 99x, that's equal to 24. So that means x dividing each side by 99 will be 24 over 99. So 0.242424, where the 2's and 4's gone forever, is the same as 24 over 99. So I'm just going to do one harder example and then we're done. So let's say I have something like 0.633. This time only the 3's are recurring. So remember, if I want to write that in exact decimal form, I only put a dot above the 3 because it's the only one that goes on forever. Okay, so I'm going to convert that to a fraction. So let's start again. I let x equal 0.63 recurring. Now we have a little bit of a problem here. I can't really times this by anything so that what happens after the decimal point will stay the same. So if I times x by 10, for example, I'm going to get 6.3 recurring. 3 is just going forever. This is not the same as that. But that's okay. What I can do is I can move the decimal point again so that it will be the same as this. So if I move the decimal point one more spot to the right, so now I'm moving it 2 spots to the right, timesing it by 100, I get 63.333, and so on. So this and this are not the same, but this and this are the same. So I'm just sort of going to forget about this one for a moment, and I'm going to subtract these two because they have the same thing after the decimal point. So now what I do is I go 100x minus 10x. So that will just be 100x minus 10x. Okay, and it's the same thing. The reason that we wanted to have the same thing after the decimal point in both cases was because they cancel out. 3 minus 3, 3 minus 3, 3 minus 3, and I'm just left with a whole number, 63 minus 6, which is 57. But 100x minus 10x is 90x, so 90x equals 57, and x is 57 over 90. So I have converted a recurring decimal into a fraction, just like that. So I know that this is a really tough topic. Please make sure you ask any questions if you didn't understand anything at all in this video. Otherwise, this has been the luckiest maths teacher in the world. Have a great day.